Welcome, and we are going to start working on specific classes of functions now. So we're starting a new module, and the first type of functions that we're going to talk about are linear functions. And so these connect nicely to linear equations, and we've actually seen linear equations before, and graphically they would just appear as equations of lines, right? So algebraically, when we worked with linear equations, we saw these three forms. So we had, slope-intercept as the first one, point slope as the second, and then this third one, we don't typically work with it that often, but it is known as standard form. And again, just to remind us of all the different symbols, y and x have to be left as a general y and x because we're working with functions, so we need to have an we need to have an input, we need to have an output, right? And so m has been known to us as the slope. Okay, and we would calculate this as, change in y over change in x, rise over run. That's the idea. And so previously that would be calculated as y2 minus y1 over x2 minus x1. And again, you'd have x1, y1 as as a point, and you would also have x2, y2 as a second point. So both of those are just points. Okay, so when we see, in the second equation, y1 and x1 appearing, those are just the y and x coordinates from that point that we pick. B, that was known as our y-intercept or our vertical intercept. Sometimes we're not dealing with y, so that's why it's better just to call it a vertical intercept in general. And then A, B, and C, these were just constant, and I'm going to actually add the word integers to them. We can't have these being fractions at all, okay? But again, we don't typically work with that standard form, okay? And so that's what it looked like from an algebraic perspective. From a graphical perspective, we might have had, if we have that vertical intercept B, we'd certainly have that point, and then, we would go over one unit and then here, and then we could construct the equation of the line, okay? But what we would see is horizontally we go a unit of 1, and then vertically we would go a distance of m, right? Because the slope is rise m over run 1, and so that's a way that we could envision the slope, okay? In a similar vein, okay, we could also say, okay, well, maybe we have just two general points. Maybe we have, here's our point x1 comma y1, and then over here was our second point, x2, y2, okay? And with that, we could construct a line like this, okay? And that would be enough for us to construct a line as well. So we either need two criteria to construct the graph of a line. We need either 2 points, as we just saw, or we need a point which could serve as the intercept, or maybe not, and a slope, okay? And then we can construct the equation of a line, or at least the graph of a line, okay? So this is fine and well, but again, we're wanting to talk about functions. And the idea with a function is that, for uh, one input we get one output, right? And graphically, we would see that it would pass the vertical line test. So, I mean, graphically, as long as we have the picture here, are these functions? And I'm going to say yes, as long as we don't have a vertical line, okay? So yes, as long as there isn't a vertical line. And if you happen to remember the equations of those would look like the equations of the form x is equal to c, okay? Those are not functions, okay? But so if we do have these as functions, right, we could talk about each of these as using the notation f of x, and this one might be a different function g of x, okay? So we can introduce notation. Great. And also, we could have actually done this before, but all the function concepts that we just discussed earlier, so domain, range, inverses, function combination or composition, and transformations all still apply. So we could use all that knowledge and just continue to build our mathematical skill, okay? Great. And so when we talk about a linear function, kind of the base one that we work with, it's typically just mx plus b. Sometimes we might use the notation ax plus b, and a is just going to represent the slope. Okay, tomato, tomato. But this is our base linear function. So whenever we say let's construct a linear model, this is the equation that we need to fill in, and specifically, you need to provide values of m and b. Okay, x and f of x should remain as unknowns because again, we need to put something in, we need an x input, and then we get an f of x value for an output. All right, so one quick example here before we wrap up. So we know f of x is a linear function such that f of 8 is equal to 7 and f of 2 is equal to -1. What's the equation of the linear function? Okay, well, fine. So we know we need to provide an answer that looks like f of x equals m x plus b, and I need to provide values of m and b. Okay, so m is our slope, so let's find our slope. Okay, so we do the calculation, rise over run or change in the y values. Okay, so now just before we go too far, each of these is an x value. Whatever we put in is an x, and then what we get out is a y. Okay, so I'm going to do, say, y2 minus y1 over x2 minus x1. Now, which one's 1 and which one's 2? Doesn't matter as long as you're consistent. So maybe let's call this 2 and then these ones 1. Okay, so calculation-wise, I would get, -1 minus 7, okay, over 2 minus 8, okay. Doing that arithmetic, let's see, that's -8 over -6, so that reduces to 4 over 3. Okay, so I found m. Great, so now I can say that this is going to be f of x is equal to 4/3 x plus b. I still need to provide the value of b. Okay, so how do I do that? Use the given information. Okay, so now I know that. So if I want to find b, I'm going to say, okay, well, f of x has a value of 7 whenever I put in a value of 8, right, plus b. Okay, so now just do the arithmetic, and this is not going to be pretty, but let's see, this is 8 over 1, so this is 32 over 3 plus b, and so then subtracting 32 over 3 from both sides, so 7 minus 32 over 3 is equal to b, and so common denominators and all that jazz means that this is going to be 21 over 3 minus 32 over 3 is equal to b, and calculation-wise, I believe that's b is going to be -11 over 3. So then my final answer here is going to be f of x is equal to 4/3 x minus 11 over 3. And that would be my linear model that satisfies those conditions. Okay? So there we go. Linear functions, just like linear equations, just with a little bit more notation.